Okay, so thank you, everyone. Today I will be talking about fuzzing with Atheris, which is a project that my team is developing. And the idea is to automatically find security bugs in Python code and also native code. So I'm Federico. I'm a software engineer within the information security engineering team at Google. I joined Google in 2015 as a SRE, so site reliability engineer. And I've actually been in SRE for a pretty long time, even though my background is security. And I always did a bit of security work on the side. And recently, last October, I joined the information security engineering team. So yeah, now I can work on security full time. And I work remotely from Trentino in Italy after spending a few years in Dublin and Munich. So yeah, today we're going to talk about fuzzing. So what is it? Have you ever heard about fuzzing? Like quite some people heard about it. Have you ever fuzzed your code? Only two people. So perfect. This is what I was expecting. So I hope the talk can be interesting for you. So let's say you have a piece of code, very simple, just one line of function to compute the mean. So yeah, maybe you want to make sure, like test this code, and you want to ensure that you take care of all the exceptions that this code could raise. So can you think of some exception that, or something that could go wrong with this code? Yeah, that's one. Something else, maybe? Yeah. Yeah, so for example, if data is not iterable, some will return a type error. Also, len could return a type error. And yeah, if the data is 0, then we get a zero division error. But did you know that also this could also cause an overflow error if you use CPython? And this is just a CPython implementation detail. So this is just an example to say that it's pretty hard to understand when you look at the code what all the possible behavior that this code could have. There are some quite obscure corner cases that it might be hard to think of. And also, usually your code is much more than that. You don't have just one function with one line. You have a lot of code. So this becomes harder and harder to do manually. So wouldn't it be great if we could generate inputs that trigger crashes or interesting code paths, so that we can do this automatically and we can figure out all the corner cases that our code can fall into. And this is exactly what fuzzing does. So fuzzing is code exploration, essentially. And a fuzzer can automate this process. So basically, in fuzzing, a function is repeatedly executed, like a lot of times, and every time with different input. And the idea is to detect bugs, basically. And Atheris is an open source fuzzer for Python code and also native libraries and that we developed. And the name comes from this type of snake, Python, I'm not sure, which is kind of looks like a fuzzy Python because it has this fuzzy skin. So Atheris is a coverage guided fuzzer, which seems like a complicated word, but essentially this is what coverage guided fuzzing means in one slide. So you start with an input corpus, which could also be empty. And then you have a function that does input mutation. So for example, if you start with a corpus of, let's say, images, because you want to test an image parser, then the input mutation will try to mutate the file of the image, and then feed it to the function that you want to test. And then you check what's happening, basically, with the execution of your function. So maybe you have a crash, and that's perfect. You can report a bug. Otherwise, nothing interesting happens, so you just throw it away. But before throwing it away, if you don't have a crash, what you can check is, did we cover new code? And if we did cover new code, then this is interesting because then what we want to do is maximize the code coverage. So then we can save this input and feed it back to the input corpus. So next time we can mutate this again and explore more and more code. And you might think, oh, how can this work? And actually it does. As of January 2022, OSS-Fuzz, which is a Google project for fuzzing open source software, found over 36,000 bugs over the years. And this was in over 550 projects, or in 550 projects. And if you're interested in more details, there's like an annual report that is published by the OSS-Fuzz people. So how do you use Atheris? You can run it on macOS or Linux. And it works with CPython versions 3.6 to 3.10. 3.11, we still have to develop the support for it, but it will happen soon. And you can just run pip install Atheris. And then you have a function that you want to test. In this case, is this test1 input function, which takes some sequence of bytes as input. And you have a decorator that tells that we want to instrument this function for Atheris. And then in the body of the function, we have a check. If the input is equal bad, then we raise a runtime error. And then we have a bit of imports and set up a code for Atheris. But yeah, this is just 2 lines of code. And so what will happen if we run this is that Atheris will figure out that the input string bad will actually cause this exception. And then it will tell you that there was an uncaught exception that was found with a specific input, and give you the input, like save it to a file called crash dash the hash of the input, and give it in different formats, like you see the hex encoded format, the ASCII one, and base64. And yeah, there are some cases where, or many cases actually, where random mutations are not so efficient and can only go that far. And for example, if you have another like slightly different function from the one from before, where the data is first decompressed with zlib, and then we check for the string bad. And if that's the case, then we raise a runtime error. And if we do this with regular mutation, random mutations, then it will take basically forever for the fuzzer to figure this out, because it's very hard for the fuzzer to understand how to generate an input that, when decompressed, will actually result in the string bad. So what we can do is actually help the fuzzer a bit. Yeah, this will take forever. So we can help the fuzzer by writing a custom mutator. And this is a relatively new feature in Atheris that was added maybe in around December last year. And basically what you can do is create, instead of using a random mutation function, you can define your own that will first take the input, decompress it, then mutate it, and then compress it again. And then give it to the, and this will be used for mutating the input. And this could be application dependent, depending on what you want to fuzz. And this can help you with like expanding the coverage of the fuzzer and be much more efficient. So before, with the previous, like if we run this code, then it would, like I left it running on my workstation for like a night, and it didn't even find the string bad. With this custom mutator, it takes like not even a second. And then it will figure out that this long sequence of bytes, which looks like gibberish, is actually what decompressed would result in the string bad, and then will cause the crash. We can also use fuzzing for doing differential fuzzing. So it's not only for finding crashes, but also to find differences between libraries. So let's say you have 2 libraries that are supposed to behave the same. For example, maybe like a JSON parsing library, or maybe something that fetches content from HTTP or does DNS resolving. So you want to make sure that 2 libraries behave the same, because maybe you use them in a microservice architecture, and you have different services that maybe were implemented by different teams. One team like to use that library, another team like to use another one. But maybe one service is doing a check on the input, and the other service is using this input. So you might have, if you have differences in how these libraries behave, you might have time of check, time of use issues. And those happen when, for example, a library is used to perform a check to sanitize the input and make sure that it's good. And another one is used to actually performing the operation. And so doing differential fuzzing with Atheris is very simple. You just define a function that gets input, gives it to the two libraries, and checks the output. Then maybe you want to have a bit fancier code that checks also exception if the exceptions are the same and so on, but this is just minimal example. And then you can find differences that way. If you saw the previous examples, all the inputs to the functions were bytes, which is not so convenient, especially because usually functions take different types of input, not just bytes. So Atheris has you covered there as well. So what you can do is either use the Atheris fuzz data provider, which is basically a function that will give you a generator of data, essentially. So you feed bytes to it, you get any type you want out of that, well, any type that is supported by the library, at least. And you can extend it if you want. And this is still convenient, but not so much. So what you can do is use the integration that Atheris has with the libprotobuf mutator, which is a library that uses protocol buffers. And basically, you can define a schema in a protocol buffer format, and then this library will mutate together with Atheris. Will mutate the protocol buffer based on the schema that you provide, and this allows you to do much more complex operations, like maybe generate inputs that you use for sequential calls to an API. Or maybe to generate a complex language like maybe SQL, or maybe a config language that you have that is custom. So how does Atheris work under the hood? Atheris is based on libfuzzer, which is part of the LLVM project, and it's a coverage-guided fuzzer that you can use generally with C, C++ code. So Atheris is basically wrapping this fuzzer and exposing it to Python. So Atheris is a native Python extension written in C++, and it allows you to call into libfuzzer helpers from Python. The thing is that Atheris works not only with C++ code or C code from extension modules, it also works for Python code. So to do that, we need to instrument Python code so that Atheris knows what is the code that is being executed and get coverage information. And this is being achieved with basically by injecting code into the bytecode of the function you want to test, and also all the imports and dependencies that you use. And basically, there is this small snippet that is added to every branch to make sure we can know when a new branch is executed and which basic blocks are executed. And if you want the coverage information from native code, you need to compile your modules with the fsanitize flag of Clang, for example. And yeah, there's some documentation on how to do that. So we recommend to use Atheris with Python 3.8+. And this is because we have a much more efficient opcode tracing that is implemented. Basically, if you think at the first example, we had the testing function that had to figure out that the input bad caused the exception. And if you just want to generate this string with just random mutation, it's pretty hard. Like, well, bad is like relatively short, so even if you try like all possible combinations of 3-letter strings, it doesn't take that long. But if you have a longer string, then it will take forever. So we want to make this more efficient, of course. So how this works is that basically for every comparison operation, then we can tell libfuzzer that there was a comparison between the input, like a certain input that maybe came from the fuzzer, and some other operand. So the fuzzer knows what comparisons are being made in the code, and it will be able to generate better input that actually pass these checks. So for example, with the string bad, then it will know that there was a condition, if condition, where the string was compared with bad, and then it will generate bad at the next iteration So with Atheris, we have a few interesting bugs that were found. For example, one was a heap buffer overflow in Pillow, this image parsing library. And this was on PCX format, which is probably very obscure. Not many people use that. And the bug was that there was some size information in the header that was actually used and trusted without doing additional bound checks. So if you could create an image with maybe very large size or very small size, and yeah, this wasn't maybe not reflecting the real size of the data structure in the image, and so you could have yeah, an overflow there. Another example is a comparison between, so this was differential fuzzing. The other two examples are differential fuzzing. The first one is Ultrajson compared with the built-in JSON library in Python. And Atheris found out that if you use a JSON containing numbers that are larger than 64-bit, then you get it coded to the wrong numbers if you use Ultrajson. Well, it's not the wrong, I mean, it depends how you define wrong, but it was basically wrapping around. So this might cause security issues, depending on your application. Another example is with the DNS resolution libraries that were treating Unicode differently. And this could be a problem, for example, if you have, let's say, you use one library to do a check that maybe, I don't know, a domain resolves to some external IP and not a local one, and but then you use another library to actually performing the request, and then you might have a difference that could result in a security bug. So running fuzzer is expensive, but luckily there's a project called OSS-Fuzz that can run your fuzzers for you. So if you work on an open source project and you have a significant user base or your project is critical for the global IT infrastructure, then OSS-Fuzz can run your fuzzer on Google Cloud, and it will handle triage, deduplication, and reporting of bugs. And if you want, you can go to that URL to learn about the onboarding process. And we already have Python projects that are on OSS-Fuzz. For example, PyYAML, Pillow, and so on. And we already have 29 bugs reported so far. If you run, or if you maintain a project in another language that is critical, then we also support other languages on OSS-Fuzz. They will not use Atheris, they will use other fuzzers. But yeah, we have C++ support with libfuzzer and also other fuzzers, Rust, Go, and Java. And yeah, as you saw before in the previous slide, there were like thousands of bugs found. So yeah, that's all I had. I hope this can be like a useful input for you to get started fuzzing with Atheris and help us finding bugs and make code more secure. Yeah, so as you saw, it's relatively easy to start using Atheris and define a test harness. So this small function that you want to test, press play, Atheris will run and like try to find bugs for you. And yeah, it's open source, so if you want to send contributions, we really welcome those. And if you want to apply for OSS-Fuzz, we also give you computational power for running your fuzzer and finding bugs. So this will help, hopefully, open source software to be even more secure. So yeah, thank you very much.
Thank you for the talk. Very interesting. We have two questions which are very connected. The first one is Atheris complementary to something like Hypothesis?
Mm-hmm. Yeah, so to be honest, I'm not super familiar with Hypothesis. I only read the documentation briefly, I never used it. But I think the main difference is that with Hypothesis, the idea is that you don't really you do so many iterations of the input generation. You don't generate so many test cases. I think by default, it generates 100 of them. And the idea is that you use it in your unit test, and you want your unit test to be fast. And also, it's not coverage guided, so it will not try to maximize the coverage. And actually, the hypothesis documentation mentions that if you want, you can run hypothesis in a more like coverage-guided fashion, but I'm not sure how that works. Or it mentions Atheris as an alternative, if you want to do that. And also other Python fuzzers, like I think it's called Python Fuzz, but that only supports native Python code, but not extensions. So that would be more limited.
Another question we have, do you think the fuzzer should run at every pull request, or is it better something like a nightly task on the whole code base?
I think what OSS-Fuzz is running it daily. So like every day there's a run of the fuzzer that will use the previous input from the corpus from the previous days and try to generate new inputs. So I think running it for every pull request is a bit expensive. And also not that critical because you don't really release code like after every pull request, usually. So yeah, running it daily, I think it's a good compromise.
Next question is, how does mutation work with empty input corpus?
How what, sorry?
How does the mutation work?
The mutation. Yeah, so we have this this one. So whenever you have comparison between, for example, for a string or a fixed value, you have callbacks to the hooks for main compare and trace comparison for bytes. And basically, this will allow the fuzzer to be able to generate inputs that can pass the various conditions. And it is actually pretty efficient to, like even if you start with an empty corpus, it's pretty efficient to generate valid inputs after a while. So it's application dependent. Like I would say, if it's easy for you to have a corpus, start with the corpus. If it's not easy, then you can start with an empty corpus, see what's the coverage level that you reach. If it's reasonable, then why bother with the corpus? The fuzzer will figure it out for you. And if the coverage is not very satisfying, then then you can try to provide some small corpus, and then over the time, the fuzzer will figure out how to expand that corpus.
Another question is, how does Artist work for business applications? Is it more applicable for low-level library usage or testing application? For example, web app using Django.
Mm-hmm. I mean, technically, you can use it also for large applications, but then it's sometimes hard to reach high coverage, because then you might have some conditions that are harder for the fuzzer to figure out and generate inputs that can pass the condition. So I would recommend that you, like it's more efficient if you run the fuzzer on a smaller piece of code where you think there might be bugs. Generally, we try to fuzz parsers because that is where most bugs lie, and the user input comes, like the input comes from the user. For example, image parsers or configuration language parsers and stuff like that. Those are pretty error-prone to out-of-bound checks that are missing and overflows and stuff like that. So yeah, I would recommend to first fuzz the parsers. But for example, if you have a web app and you want to fuzz the web server, then yeah, fuzzing HTTP request parsing is also an interesting one. But yeah, fuzzing the whole application that's very large, it's probably not so efficient.
Okay. Other question is, do you have any recommendation on best practices when writing custom fuzzers to avoid missing all possible cases?
Mm-hmm. Yeah, so there are a few advice when you write a fuzzer. For example, ideally the test function should not mutate state, because then it's hard for the fuzzer to figure out that the initial state is different. So then whenever the function will be run again, the initial conditions are not the same, and then it will produce inputs that maybe trigger a crash, but the crash was dependent on some previous state, and then it will not be reproducible anymore. So yeah, you want usually your fuzzing to be reproducible as much as possible. It should be, if you can, limit it to a small function, because then you can reach high coverage on that, and where you think your bugs might lie, and then it's more efficient. Yeah, if you have code with that do, for example, a lot of logging, sleeps, or something that is not relevant for the fuzzer, then it would be better if you have a mode in the code that can be used by the fuzzer so that those operations are not performed if they are not critical for the application, like disable logging, disable whatever sleeps if you have them, or I don't know, anything that might not be relevant to finding bugs. And I don't know, that's it from the top of my head. But I'm sure you can find other tips on like libfuzzer documentation.
Okay, another question we have is, what were the results of running Atheris on the Android source code? They're also wondering if it will make harder for spyware like Pegasus or Candiru to infect smartphones.
So I'm not super familiar with the fuzzing of Android, of the Android code base, but I believe yeah, both my colleagues and people outside of Google are doing that, mainly because it's pretty, like, people are interested in Android bugs for improving security, and not only. So yeah, we have a vulnerability reward program. So if you find bugs, you can send them to Google and you get a reward for it. And so there are many external researchers that run fuzzers on the Android code base. I don't know how many bugs they find, but I'm sure there are some good results there. And yeah, I know the Linux kernel is continuously being fuzzed, also to find bugs. The harness is a bit more complicated because then you need to fuzz the syscalls, and you need to make sure that you can restart the kernel when you end up in a kernel panic. So it's a bit more complex, but yeah, people do it and it works.
All right. So those are all the questions. If anyone, we have like 1 minute for other questions. If anyone wants to ask now, person. Okay. If not, thanks again. Big round of applause for Federico.